Hey, grade nines. I'm hoping you found the website okay and everything is looking all right for you. You might notice that we have a test that has been posted, but we haven't had much time to practice to review. So I'm going to give you a couple of review pointers on things that you might see on the test. And we're going to actually start here with collecting like terms. Okay, so I've got an example here. If you know how to solve it, you may as well give it a try. Maybe pause the video and try it out. If you don't remember though, I'm going to go through the solution and we'll see if we can solve it. I don't think I would give you something this difficult on a test, but if you can handle something like this, I'm sure you can handle any collecting like terms problem. So the first thing you have to do is identify the things that are in common, right? So you don't have to write anything down, but it's a good idea to point them out. In our notes, we put shapes around things that were the same. For example, use a red marker over here, and I'm gonna put a box around anything that is an x squared. So I've got one here, which is a 6x squared. And if I look through here, I actually do have another x squared. It's right over here, so just a regular x squared. Notice though, I put a box around the sign in front of it as well, because that's going to be important. Because the next thing that I'm going to do is I'm going to write down whatever I boxed in red. And as you can see, it ends up becoming one of the more simpler addition problems. If I didn't have the sign there though, it might be a little difficult to understand, right? So we're not done there yet though, because we have a few other things that haven't been accounted for. I'm gonna use a green marker this time, put a box around anything that has a y in it, because the y is the next thing that I'm seeing. So there is a plus 2y, and if we look a little bit further on in the equation, we have a minus 3y as well. And if we look through the equation, I don't see any more y's there, so I'm just going to write down the y's that I've boxed in so far. Okay, so it ends up that we just rewrite the equation that we started with, but we're rearranging it so that's a little bit easier for us to solve. I've got a few more things to highlight here, so I'm going to use the orange marker here now and highlight things that just have an x in them. Now I understand that there's an x squared. An x squared is different than an x on its own. Okay, so let's see if we can find some x's, and you'll see that the first thing we see is a negative 3x. So we're going to highlight that one first. Over here. And I have a positive 3x, so I'm going to highlight that one as well. Okay, and as before, we're going to rewrite the equation. So almost everything is accounted for. I've got one last thing here, and that's a unit by itself. That's the plus 1. If you want to circle it, you can. I'll put a box here on just to be thorough. I mean, if you see that it's by itself, you don't have to put the boxes around, but sometimes they help us out, because now everything is color-coded, and if we made a mistake, we can go back and see what our mistake was. Assuming we didn't do a mistake, and we work with what we've rewritten down over here, we can now actually do some of the math. So we're going to start with the red, which was a 6x squared plus an x squared. Well, I've got 6 of the x squareds over here, and it looks like I have another x squared over here. So in total, I should have 7 x squareds. So now we're moving on to the y's. So those are the green ones. I have 2 y's minus 3 y's. My negative number is bigger than my positive number, so my answer is going to end up being a negative. I get 2 minus 3, which is a negative 1. You might notice I didn't even write a 1 here, I just wrote it as y. That's because we don't typically write the 1s. They make the polynomials look a little bit more difficult. They kind of look like L's or I's, so we don't like to have them in there. The other way to think of it is 1 times anything is just itself, right? So if I did 1 times y, I just get y. So that's why we don't write the 1s there. But if you'd like to, I have no issues with you putting them in there. It's just you won't see them in your practice. Now moving on to our oranges, you'll notice something else that's a little bit strange here. I've got minus 3x plus 3x. Minus 3 plus 3 equals 0. And 0 times anything is just 0. So it turns out you don't even have to write that part. They end up canceling each other out. In fact, in your previous statement, I would just go and cross both things out. So we cross both those terms out because they zero out. So we don't want to get confused by them later on. I'm writing it there just so that we have some clarity on it, but you don't have to write zeros in your equations. Sorry about the weird cut there. I just had someone come in the classroom while I was recording, and I'm not very used to this yet, so it's a little bit weird. So sorry, I was mentioning that when you have two terms that cancel each other out, you end up getting a zero, and you don't have to write the zeros down. They just cancel each other out. So I'm writing it there for clarity's sake. You don't need to have it there, though. We can just not write that zero. The last thing is that 1, which is by itself. Because 1 has no partner to add or subtract with, we just rewrite it. Okay, and essentially that is what your final answer would be, but we have to clean it up a little bit. We don't like to have our zeros in there, so I'm just going to rewrite the whole thing one more time. You don't have to color code it or anything like that, just so that we understand where the numbers come from. I'm left with a 7x squared minus y plus 1, and that would be your solution.